Some trig review from high school. Two expansion formulas, sine x plus or minus y, in terms of sines and cosines, and also cosine x plus or minus y. And also, here are some known values. We can do these from simple triangle constructions for 0, 30, 45, 60, and 90, and their radian equivalent. Here's all the sine, cosine, and tangent values for theta. If you had high school trig, which you should have, you've probably gone over these values. We're going to look at a couple examples. Sine of 75 is sine of 30 plus 45, which we can expand it using this formula. Plus here matches with plus here. And so we're going to write that as sine 30 cosine 45 plus cosine 30 sine 45. And then we put the exact equivalent in. Sine 30 degrees is equal to 1/2. And then cosine 45 is square root of 2 over 2. And then cosine 30 is equal to square root of 3 over 2. And then sine 45 is equal to square root of 2 over 2. Nope, that's times. And so that's square root of 2 plus square root of 6 over a common denominator of 4. That's an exact value that we can derive. Now, second of all, cosine 15 is cosine. You can do that as 60 minus 45. Or you could do 45 minus 30. Take your pick. It doesn't really matter. Now, the cosine formula, cosine minus, you have to use a plus in between these two terms. It switches. And so we have cosine 60 cosine 45 plus sine 60 sine 45. And of course, cosine 60 is 60 cosine is 1/2 times cosine 45 square root of 2 over 2 plus sine of 60 square root of 3 over 2 times sine 45 square root of 2 over 2. This should look strangely familiar. Square root of 2 plus square root of 6 over 4, which not surprisingly is the same as sine of 75. Okay. 15 and 75 are complementary angles, and the cosine really is a complementary function of the sine, so we always have this identity relationship. So, okay, that's part one. We'll be back shortly for part two.